Alright, so first we are going to finish up that last problem in the salmon colored notes, the sum and difference identities. We're going to take a look at this last problem where it says to verify that the tangent of theta plus pi over 2 is equal to negative cotangent theta. So if we were to expand this out, don't write this down, but if we were to expand this out, we would have tangent of theta plus the tangent of pi over 2 all over 1 minus tangent theta tangent pi over 2. We would then look at pi over 2, just straight up, has an ordered pair of 0, 1, and we know that tangent is y over x, so that'd be 1 over 0, and that is undefined. So we cannot verify the left is equal to the right using the expansion of tangent. So we need to figure out a different way to find that the left side does in fact equal the right side. So what we're going to do instead is we know that tangent is sine over cosine. So we can do the sine of theta plus pi over 2 over the cosine of theta plus pi over 2. So we're going to first expand out the sine. So this is sine theta cosine pi over 2 plus cosine theta sine pi over 2. And this is all over, expand out the cosine on the bottom. Cosine theta cosine pi over 2 minus sine theta sine pi over 2. Okay, so the sine of theta is just sine theta. The cosine of pi over 2, cosine is an x value, so that's 0, plus cosine of theta times the sine of pi over 2. Sine is a y value, that y coordinate is 1. All over cosine theta times cosine pi over 2, which again is 0, minus sine theta times sine of pi over 2, which is 1. Oh, hold on. The video froze. Let's try this again. Okay, sorry about that. So we expanded out the numerator, expanded out the denominator, then we replaced our functions with the pi over 2 with their values using the 0 and the 1. So sine of theta times 0 cancels out. Cosine theta times 1, that's just cosine theta, over cosine theta times 0 is gone, minus sine theta times 1, that's a negative sine theta. Cosine over sine is cotangent. Because this is negative, it means it's a negative cotangent theta. And that is what we were trying to verify. Okay, so that takes care of the salmon. What I'd like for you to do next is take out the green, or somebody needs to pass out the green one. It's the more practiced sum and difference. Looks like that. And let's take a look at the inside. So it says, it is known that the sine of alpha is equal to 4/5, and alpha is between pi over 2 and pi. So if that's the case, what quadrant are we in? If alpha is between pi over 2 and pi, that puts us in quadrant 2. So this is our alpha triangle. Sine is 4/5, so the opposite side is 4. Hypotenuse is 5. The base then is -3. And you can put this below part A and part B if you're looking to where to put this. This can go below part A and B because A and B don't take up very much space. Then we also know that the sine of beta is equal to -2 over the square root of 5, and beta is between pi and 3 pi over 2. So between pi and 3 pi over 2, that means we are in quadrant 3. So this is my beta triangle. Sine is -2, so the opposite side is -2. The hypotenuse is square root of 5. So using the Pythagorean theorem, we can get the base of this triangle. So we're going to do 5 minus 4, which is 1. Square root of 1 is 1. But it's going to be negative because we're going to the left. So those are the two triangles that we're going to use. Part A is asking for the cosine of alpha. So we're just going up to our alpha triangle, and we want to take the cosine of that triangle, which is -3/5. Part B is asking for the cosine of beta. So we're going to look at our beta triangle, and the cosine here is -1 over square root of 5, which is negative square root of 5 over 5. Part C is asking us to find the cosine of alpha plus beta. So we can go ahead and expand that out. Cosine alpha, cosine beta, minus sine alpha, sine beta. Now we're just going to take our ratios and plug them into the appropriate place. So the cosine of alpha is -3/5. The cosine of beta is negative square root of 5 over 5. Minus the sine of alpha that was given. Nope, we're paused again. I don't know why that keeps doing that. Alright, so all we've done is we're just plugging and chugging here. So we've got -3/5, negative square root of 5 over 5, minus the sine of alpha we're given up above is 4/5, and the sine of beta, it bothers me that that radical is in the denominator, so I'm going to rationalize -2 square root of 5 over 5. So go ahead and multiply, so we get a positive 3 square root of 5 over 25 minus a negative, so it becomes plus 8 square root of 5 over 25. And then we just combine our like terms. 8 plus 3 is 11 square root of 5 over 25. So that's part C. Go ahead and try part D on your own. Sine of alpha plus beta, go ahead and pause the video. Take a couple minutes and then you can restart the video. You should get 2 square root of 5 over 25. All right, so let's take a look at the inside. Upper left corner. Establish the identity that the cosine of alpha minus beta over sine alpha sine beta is equal to the cotangent of alpha times the cotangent of beta plus 1. So we're going to work on the left-hand side. In the numerator, we're going to go ahead and expand. So cosine alpha cosine beta plus sine alpha sine beta. This is all over sine alpha sine beta. Okay, so what we have here in the denominator, this is one term because the two functions are being multiplied. In the numerator, we have 2 terms because we have the addition sign in the middle. So what we're going to do is we're going to take this one fraction and we're going to split it apart into 2 fractions with that common denominator of sine alpha sine beta. So cosine alpha cosine beta over sine alpha sine beta plus sine alpha sine beta over sine alpha sine beta. Okay, well, cosine alpha over sine alpha, because they both have an alpha, we can write that as cotangent alpha. Cosine beta, sine beta, those both have betas. Cosine over sine, that's cotangent. So this is a cotangent of beta. Then sine alpha over sine alpha cancels. Sine beta over sine beta cancels. So this simplifies to 1, and that's what we were trying to get. So these verifiers are a lot different than the ones that we were doing in the last unit. Okay, so you know it was kind of coming here, some of the trickier ones. So let's take a look at the upper right corner where it says to find the exact value of sine of the inverse cosine of 1/2 plus the inverse sine of 3/5. So what we're going to do is we are going to think about the inverse cosine of 1/2 as being our alpha and the inverse sine of 3/5 as being our beta. So what we're really looking at here is our expansion of sine alpha plus beta. So sine alpha cosine beta plus cosine alpha sine beta. So that's what we're actually going to be trying to solve here in a moment. But let's talk about this alpha and beta. Okay, so what we're saying is that the inverse cosine of 1/2 is equal to alpha. What does that really mean? It means that the cosine of alpha is equal to 1/2. So how can we get the sine of alpha? Because we're going to need a sine of alpha here. Well, inverse cosine, it's positive, so we're restricted to quadrant 1. Well, this is one of our special right triangles, so this is the square root of 3. So that means that the sine of alpha is square root of 3 over 2. Okay, let's go back up here, take a look at our sine. Inverse sine 3/5, that's equal to beta. So sine of beta is equal to 3/5. Okay, so that takes care of sine beta. So now we have cosine alpha, sine beta, we need our cosine beta. So again, this function, inverse function of sine, is a positive 3/5, so that means we're in quadrant 1 also. So what's the base of our triangle? That's a 4. So that means that the cosine of beta is 4/5. And again, if you want to label this as your alpha triangle and that is your beta triangle, that's fine. So now we're going to go back up to our expansion and we're going to plug in those values. So sine of alpha, that's square root of 3 over 2, times the cosine of beta, it's 4/5, plus cosine of alpha is 1/2, and then the sine of beta is 3/5. So when you multiply, we get 4 square root of 3 over 10 plus 3 over 10, and that's just 4 square root of 3 plus 3 all over 10. So now we're going to take a look at the same thing, but not having actual ratios here. Sorry, actual ratios here. We're going to take a look at if we just had variables. So we're talking about the sine of the inverse sine of u plus the inverse cosine of v. And it says to write it as an algebraic expression containing just u and v. That is, without any trig functions. So we're going to start it like we did before. This first term inside the parentheses, we're going to call that alpha. The second one we're going to call beta. So we'll be doing the sine of alpha plus beta. So sine alpha cosine beta plus cosine alpha sine beta. Okay, so we're going to start with that part first. So let's go back and look at alpha. We're saying that the inverse sine of u is equal to alpha. That means that the sine of alpha is equal to u. Let's talk about some restrictions here. So we know that when we do our inverse function, we are restricted to when we solve our answer, we're restricted to quadrants 1 and 4. So that means that alpha has to be between negative pi over 2 and positive pi over 2. And when we take that inverse, what can we take the inverse of? Well, we're taking that inverse of u. We have restrictions on u as well. We know that we have to be somewhere between negative 1 and positive 1. Because if we're bigger than a positive 1, we can't have a triangle, because that means that the hypotenuse is smaller than one of the legs. Same thing if we have the negative. Again, that negative just tells us direction. Okay. So, because the sign of alpha, because alpha, there we go, is in quadrants 1 and 4, what does that tell you about the cosine of alpha? Cosine of alpha has to be what? If we're in 1 and 4, it means that cosine has to be positive. All students take calculus. So they're all positive in 1, cosine is positive in 4. So the cosine value has to be greater than or equal to 0. Okay. We're going to do the exact same thing, but this time we're going to do it with that inverse cosine of v. So the inverse cosine of v, that's equal to beta, which means that the cosine of beta is equal to v. Okay, so let's talk about the inverse function for cosine. We know we cross off quadrants 3 and 4. So beta is between 0 and pi. And what are we taking the inverse of? Some ratio v. Again, that ratio has to be less than 1. If it's more than 1, we don't have a triangle. Okay. So now let's talk about beta. So because beta is in quadrants 1 and quadrant 2, what's true about the sign of beta? Well, what do we know about sign values in 1 and 2? They're positive. So that means that the sign of beta also has to be greater than or equal to 0. So I'll give you a minute to process that. Okay, so far what we have are sine alpha, and we have cosine beta. Sine alpha, cosine beta. We're missing cosine alpha and the sine of beta. So let's talk about that cosine of alpha. Let's just think about some triangle. Okay, we know that the cosine is v over 1. How are we going to figure out what that value is, what the sine of alpha is? Well, we're going to take our 1 and square it. We're going to subtract off v squared, and then we're going to take its square root. So the sine of alpha is equal to the square root of 1 minus v squared. Not alpha. Beta. sorry, I was working with two different triangles. I'm sorry. The cosine of beta is v. So here's our v. There's our 1, v over 1. Question is, what is our sine? We need to figure out what is that opposite side. How can we find it? Using the Pythagorean theorem. So 1 squared minus v squared. Take the square root, and we have that sine ratio. Alright, let's take a look at the alpha triangle. For our alpha triangle, we know that sine of alpha is u. So that means the opposite side is u. The hypotenuse is 1. Question is, what's the cosine of u? Not the cosine of u. Oh my goodness gracious, too late. What is the cosine of alpha? Well, to get this base, we're going to take the hypotenuse squared minus the opposite squared and square root it. So cosine alpha is 1 minus u squared. So now we have sine alpha, cosine beta. We have our sine beta and our cosine alpha. So now we can take all of that and we can plug it back in to the expansion that we wrote at the top. Okay, so we start with sine alpha. Here, let me rewrite this expansion. Okay, so sine of alpha we identified as u. The cosine of beta, we identified that as v. Plus, the cosine of alpha, we identified that as the square root of 1 minus u squared. And the sine of beta, we identified that as the square root of 1 minus v squared. So that is your final answer. And I know that looks terrible, but that is the final answer. All right, we're going to do one more. And it's the solve sine theta plus cosine theta is equal to 1, where 0 is less than or equal to theta, which is less than 2 pi. Okay, so the first thing I'm going to do here is I am going to square both sides. So I have the quantity of sine theta plus cosine theta, quantity squared, is equal to 1 squared. So sine plus cosine quantity squared, that is a sine squared theta plus 2 sine theta cosine theta plus cosine squared theta, and that is equal to 1. We have a sine squared and a cosine squared. Sine squared plus cosine squared, that's equal to 1. So we have 1 plus 2 sine theta cosine theta, and that's equal to 1. I want to set this equal to 0, which is nice because I can subtract 1 from each side. So I have 2 sine theta cosine theta is equal to 0. So now we can apply the zero product property. This is like saying 2xy equals 0, so therefore x must equal 0 or y must equal 0. This 2 is really insignificant. We're concerned with what those angles are. So sine theta is equal to 0. Okay, so that's talking about our y value, where the y value is 0, to the right and to the left. where theta is equal to 0 and pi. We cannot say 2 pi because up here it tells us that we have to be less than 2 pi, but we are allowed to equal 0. And then the other part, we can say that cosine theta is equal to 0. So that means the x value is 0, so we're not going left to right, we're only going up and down. So that occurs at pi over 2 and 3 pi over 2. That last example you can cross off, we're not going to do that. So I apologize on that last example for confusing my angles, apologize. Tomorrow in class you'll just be working on an assignment, so no homework tonight. If you have any questions, please make sure you jot those down and be ready to answer those, or be ready to ask those.